Welcome back. This is Chin again, and today I'll be discussing about a very important and interesting concept in Kafka. It's around transactional producers. So basically, if we compare any relational database, what's transaction over there? Basically, any relational database will follow that as a property. You have an option to basically, when you do any kind of an operation which changes the state of a database, you create any record or update or delete, and you do a couple of tables, couple of rows, you make changes, and you have an option to either commit or roll back. And database management system will ensure that to other users, this should be visible once this is transaction committed. Of course, depending on this isolation level, I'm assuming that there is a repeatable read or read committed. So something similar what we have in a relational database, we also have in Kafka. But however, inherently, it is a little different what database does. So when you, when you commit, then everything will be available in the database, and any other transaction should be able to read that. How it works in case of Kafka. So Kafka, this is done on the producer side. So think about like a producer is pushing some of the messages and you want to keep it transactional. So which typically means when everything is done, as a producer typically will begin a transaction, it will send some kind of messages, a couple of messages, so 10 messages, 20 messages, whatever, it sends that, and finally it says commit transaction or rollback, depending on the business use case or like if a genuine error occurs or whatever. Now, on the consumer side, the consumer application, the consumer library will buffer all these messages. It will not, display all these messages to the consumer until and unless the transaction is committed, and how it does that magic. So typically, let's say on the producer side, you are pushing 20 messages or 10 messages. So when you begin the transaction, the producer will send a special, the producer library of Kafka will send a special marker begin transaction message in Kafka. And any consumer which is reading that marker for that transaction, it will understand, okay, I'm going to get a couple of more messages, but until and unless this is committed, I will not make it available to the consumer application. And then consumer library will actually buffer all these messages, but it will not make it available to the consumer consuming application. Right? So, so again, just quickly want to rephrase how it works. When a producer pushes some messages, when the transaction is begin, a special begin transaction marker message is sent, and then the actual messages are sent to that topic. And then finally, let's say if it is committed, and another marker message will be sent for commit. And that's where consumer library will understand, okay, I have got a begin transaction message, a marker message, and then all the other messages. And now I have got my commit message, which means I need to make it at once available, all these messages to the consumer application. So that's how it works in case of Kafka. So let's quickly see in terms of coding, what all is needed. So the very first thing is the configuration. It's very super simple. I'm assuming that you have already, in my previous video, might have watched it. You already have this project. Basically, you need to check out this project. I'll put the link in the YouTube, and you need to just check out the transactional producer branch for this code. Okay, so let's get back to the code. So there's you have to create producer factory. I'm just making it transactions to say it like explicitly transactional, so we understand, okay, this is a transactional producer factory, and the only property it needs is basically transactional.id. So however, you can see here transactional.id, and just whatever name you want to give to this producer, I'm just giving my transactional ID. So just by introducing one property, it will make your producer, the producer library smart enough to make a producer transactional. It will make it idempotent equals to true, and like whatever is needed to make this producer a transactional producer, that all magic is done by just introducing one single line. All right, so now once you have this producer factory, You can just get a Kafka template out of it, something like which I've already in my previous video might have already said I'm getting simple producer or generic message producer. That's it. Now this I'm calling a Kafka template underscore transaction. So now once you have this bean, I just created another file. I'm just calling it Transactional Producer. Auto wire that bean over here. Now this producer, this Kafka template is a transactional Kafka template. Now this is my method. So my use case, what I want to show is to a topic, I want to push a couple of messages, and between each message, I want to sleep for some time so that you can actually view what is happening. You have a time to view, okay, these messages are being pushed, and whether they are visible on the consumer side or not, that we can showcase. All this controlling, I want to do it from the test program. I'll come to the test later, but for now, I just pass topic, the messages list, and every time, what is the time difference. So this is a small println here. I'm using genutil.println, which is nothing but the same as out. It just prints the date format and the thread ID as well. I should be using the lombok @log. I'll take care next time. Okay, so now this is my Kafka template. There is a method called .execute in transaction, and it will pass you the Kafka operations callback method. Now, it has only one method. Whatever happens between these two braces, basically the highlighted code, it will be in the transaction. It will run in the same transaction. So now here, every message I'm iterating it, I'm just printing a small, like, 0th of 10 message or 6th of 10 message. So you know how much time is left, how much it has processed out of how many. And I'm just putting the message and what topic. Just a small minor information. Now, main thing, another important line is here from the Kafka operations.send. I'm sending a producer record to the topic, which I'm passing over here. And then that particular message, I'm deliberating saying .get because I want to push that message and want to get the meta information so that I can print it over here. Think about it, till everything is completed, basically, this is doing operation. Until and unless this whole loop is completed for all the messages, if anything goes wrong in between, this will be rolled back. This will not be visible on the consumer side. You can try on your own, just take it as an exercise, but trust me, I have tried it. And if there is an error, if you put like, okay, 5th message, throw some error for some reason, this will not be visible on the consumer side. We'll quickly see in some time. And once everything is done, which means this doing operation is done, which happens in the same transaction, I'm just printing execution time. Okay. All right, so now only thing left is the test case. Okay, let me make it a little higher. So the 20 messages, I want to prepare 2 lists. Why 2? I'll tell later. But for now, I just created 2 list of random names. This is a small utility method. The only thing is, like, if you pass number of characters 4, this will give me a random string of 4 characters. It's just like, to validate, to quickly create some kind of a dummy data and nothing else. Okay, so list 2 I'm not using, at least for my run. I'll just enable it next to run, which will answer me some of the questions which I'm looking for. But for now, think about, like, you have a message list 1 of length 20, and every string is of fixed length 4. Now I start my thread pool and I just submit it. Why submitting in a thread? It could have done in a main thread, but in my next run, I want to run these 2 things in parallel because I want to answer for a few questions, which we'll discuss later. But for now, I just want to run it in a separate thread, and I want to sleep for some time, give it some time for this program to get completed, and we'll see the result. All right, so this is my setup. And now you can actually see over here that my transactional topic is TXNALT001. And that's what you can see in my Kafka drop. If I see my view message, yes, there is no message. If I go, there are already some messages. I don't want to display them. It's just a noise. So I'm just making it 119. That's it. So now even a single message comes, and if I click on view message, this will refresh and we should be viewing any new message comes over here. Perfect. So let's get started and let's run this program, which should be pushing 20 messages in a transaction in a difference of 1.5 seconds each. So we have a plenty of time to actually see on the Kafka drop. So now we see now my 0th of 20th and 1st and 3rd and 4th of 20th message is going to push some kind of a random 4-digit string, 4-character string. 8, 9. And now still if I click on my view message and this refresh successful, I don't see a single message over here because it's still the transaction is not committed, and this will be committed when my execution done is printed. 18, 19, 20. Now if I click, immediately all the 20 messages will be visible to me. So that's pretty much, I mean, still my program will wait for some time because I have given a 1 minute and still there's some time left over here. So I think this makes pretty clear that what exactly is a transactional producer, and this showcase that, you know, either everything will be successful or everything will be rolled back. So rollback I have not shown. I'm sure you guys can try on your just throw some kind of an exception when some condition met, and then you see on your consumer side that nothing is visible over here. All right, so let me look at something. 39, 43, 5, 6. Perfect. Now again, there's no noise. I'll be seeing the message now here again afresh. Okay, so now you'll be wondering why list and what answers I get. So here I am deliberating giving a very large number. By the way, if you see over here 143 or something, you see that message of 4 characters have started coming over here. AG, XJ, these are all has been pushed because my message 1 is a 4th character, 4 fixed length, 46. Okay, so this time what I want to do, I want to create another list as well, which is a large fixed string. So we just quickly visible which message is where. I want to uncomment this code as well. So now my 2 threads will get started. They will pick 2 different tasks on the same topic. This topic has only 1 partition. On the same topic, the list 1 and list 2 both will be published by 2 different threads, and which means individual thread will call this method and they will be in transaction. Okay, so now why I'm doing it, because I want to get an answer that, you know, if I am pushing 20 messages in this thread over here and 20 messages in this thread over here, how the offset is internally distributed. Is it like the first 20, they will happen like in parallel. They will take, this guy will take some time, the first message will go and the second message will go and the third message. In the same time, this is also pushing some messages. How the offset gets distributed? Do they get 0 to 20 for the first one and 0 to 19 for the first one, or and 20 to 39 for the second one? Or is it like they get the offset as and when they are reaching? So let's get it started. Okay, so we see now that through 2 threads started, we can see typically thread 1 and thread 2, they both are pushing messages over here, but still you will not see anything over here because, yeah, because none of them are committed. They will be similar message counts. So they will be committed more or less in the same time. Let's wait for a couple of seconds till this is reaching to 20. Just want to refresh one more time just to show you nothing comes here until unless that is committed. Perfect. So execution done for both of them. Let's click it. Now we see there are like approximately 40 messages here because 20 for 4 length and 20 for 20 length. So we see that at offset 147, this message is gone. 148, another 4 character message is gone. 149, again 20 character message is gone, and 150 again 4 character message is gone. So basically we see that this does not reserve all the offsets in a batch. However, still the offsets are distributed as and when the messages are coming, even if they belongs to the different transactions. So that's pretty much, I think I found it very interesting, and I hope you guys have enjoyed it. If you enjoy, please like the video, so that gives me motivation to create future videos for you guys. Thank you.